Hi everyone! I hope you're having an awesome HashiConf. Today I'm going to be talking to you about Packer 2.0, what is changing, and why I think it's going to knock your socks off. My name is Marsh. I'm the engineering lead for Packer. I've been maintaining Packer for 4 years, and I've been the lead for the project for the last 2. My GitHub handle on GitHub is Swamp Dragons, for those of you who have interacted with the tool there. So this talk isn't about me, though. It's about what you as users will need to do to prepare for our transition to Packer 2.0, and it's about why I'm so excited for you to upgrade. I want all of you to have the best possible experience using Packer, and all of the stuff I'm going to touch on today is designed to make sure that your experience with Packer is better and designed to make sure that the Packer community is set up to thrive. We're going to talk a little bit about all of the forwards-looking and therefore backwards-breaking changes that are part of the 2.0 upgrade so that you can get your feet under you long before you ever have to flip the switch on installing and using 2.0. So there are a few pieces to today's talk. First, I'm going to talk about the introduction of the new command Packer init. We've made several architectural changes to Packer to make it easier for the community to more easily create, share, and install plugins for Packer, but there are some important implications that come with these changes that you really do need to be aware of. And then the second part of this talk is that I'm going to be talking about HCL templates. We love the new HCL templates, so much so that we're confident that you'll love them too, and we're going to deprecate the legacy JSON templates as well. Finally, I'm going to give you a sneak peek at some of the great stuff to come once we've made these huge changes. So first, before we dig too deep into the init command itself, I think it'll be really useful to everybody to get a quick primer on Packer architecture. And for those of you who saw my HashiConf US talk a couple of years ago, not a lot's changed since then, but I'm going to be talking to you about changes that are about to come down the pipe. So Packer uses 4 major component types to perform all of its custom functionality. If you've written Packer JSON templates, you're going to recognize the categories listed here: builders, provisioners, post-processors, as root level fields in the Packer template, and you probably have a general understanding of what they do. For example, builders create instances, manage the instance lifecycle, and then create artifacts based off of those instances. Provisioners modify the instances when they're running, and then post-processors modify the artifact once an instance has been shut down. Now, the Packer core talks to all of these components individually, and it orchestrates the builds based on your template, plugging the components you request into the right places in the core build. And that's where we get the concept of Packer plugins. Packer doesn't care whether a component is bundled into the Packer core or whether it's an external binary. It just runs each component as a subprocess and talks to each one separately over a custom RPC. So I use these terms, plugins and components, kind of interchangeably on that slide, but there is a difference between the two of them. A plugin is a binary that Packer actually installs and can talk to. The component is a Packer-specific piece of code that fulfills one of those 4 interfaces: provisioners, post-processors, builders, and the new HCL-only data sources. And they talk to the Packer core over that RPC. Now, historically, there's been a one-to-one relationship between plugins and components, which means that if you wrote a standalone plugin for Packer, it would serve exactly one component. Now, the name of your plugin on the file system would tell Packer what component type it was, and that name of the plugin on the file system would be what you use in your Packer template to actually call the component. Now, this was really useful for one-off plugins, but it could get super hairy in complicated cases. So, for example, let's say that you are a cloud compute vendor, or you work for one, and we're going to call it Happy Cloud. You want to integrate as Happy Cloud with Packer to make it easier for your users to use and create Happy Cloud images. But you have a lot of components to write for Happy Cloud. You want to write a builder, or maybe 3 or 4, depending on how complex your cloud platform is. You want to write one of the new HCL exclusive data source components, which allows users to set a variable based on an API call or other custom function. And of course, you want to have import and export post-processors for moving images into and out of your cloud. Now, to use your Happy Cloud tool, you're going to find out that your Packer using users have to install half a dozen Packer plugins to make their Packer component work, one for each builder, data source, and post-processor that they want to use as part of their Packer build. Now, faced with the prospect of creating and maintaining and forcing your users to install all of those different plugins, you might be feeling like rebranding. Now, historically, to solve this issue, what we've done is just vendored everything everyone could possibly want from all of the major cloud providers into the same Packer binary. But what that means is that a binary that started really small over the years has gotten bigger and bigger and bigger, to the point where if people want to use the Happy Cloud Builder and the shell provisioner, they're not just installing those components, they're also installing every single component written for Amazon, Azure, Google, and any and all supporting libraries for each of these plugins. So to solve this headache for our community, we've decided to totally re-architect plugins to be able to serve more than one component from a single binary. This allows people to fire up different Packer components and bundle them together based on the technologies they interact with rather than on the interface that they fulfill. So instead of having a dozen Happy Cloud Builder components, what we would have is one Happy Cloud component, one Happy Cloud plugin, and from there you'd be able to install one Amazon plugin, one Google Compute plugin, one Docker plugin, but only if you actually need them. And you can kind of think of multi-component plugins as analogous to Terraform providers, which are often logically grouped in the same way. We've also created a scaffolding template to make it easy for our users to create new Packer plugins for vendors like Happy Cloud, and this scaffold doesn't just give examples of how to write and architect plugins. It also provides a GitHub action workflow that enables users to standardize the plugin release process across the community. And that's super, super handy now that it's time to talk about what our users are going to gain from the new plugins. And that is a simple, easy installation process via the new CLI command, Packer init. Now, instead of writing the code, building it yourself, and adding it to your Packer directory, all you have to do is add a required plugins block inside of your HCL template and call Packer init. All of the install and download of the required plugins is handled in your current working directory. And then Packer will say, okay, I know what you need. I'm going to go up to GitHub. I'm going to pull down the correct version for your operating system. And that might sound like magic. So let's talk a little bit about how it works. Now, instead of requiring plugin maintainers to add their plugins to a centralized repository, all we're doing is treating GitHub as the registry instead of using a registry like the Terraform registry. As long as plugin binaries are released with the correct names on GitHub, Packer can find them and pull them down from GitHub for you. This explicit specialized naming convention allows Packer not only to grab a binary for the right release version, but also for the right operating system architecture for your build. Now, in the future, we want to add support for other domains so that you can download from wherever you want. But we're hoping that for now, the GitHub use case will pretty much cover most of everyone's needs, and manual downloads will fill the gaps where that doesn't work out. Those specialized naming conventions are why the release GitHub action that I alluded to earlier is going to be so super useful for maintainers. It handles all of the specialized naming for you, in addition to making sure that when you're building the plugin, that building is absolutely trivial, because from a maintainer perspective, all you have to do is push a semantic versioning tag up to GitHub, and the GitHub action will handle everything else. Now, there's one other issue that Packer has had with community plugins, and that's discoverability. It was really important to us when we were redesigning all of this workflow that the official plugins were documented just as well as the community plugins, which we think are equally important. And we wanted to make sure that people who want to create and use community plugins can find them just as easily as they can find the official ones. So what we've done is we've had this same Packer scaffolding repository also set up a remote documentation repository. And that means that the Go Releaser action will create a zipped document folder that the Packer website can retrieve at build time, and that means that the official plugins live side by side with the community ones, documented equally on the website, even if they're not bundled with the main Packer binary. All plugin maintainers have to do is add a few extra lines of configuration to the Packer website core code, and that'll tell Packer where to look for the remote docs that need to be surfaced on the site. This means that plugin discoverability is going to be dramatically improved for our users. But another benefit that you're going to get is now you can pin plugin versions to make sure that Packer chooses and downloads the correct plugin for your particular template's needs, which will hopefully prevent any nasty surprises if you haven't run your Packer build in a while and someone decided to upgrade in between. Now, you can already use Packer init and multi-component plugins with Packer 1.7. They're compatible with the 1.7 release series. Not only that, but over the last couple of months, the Packer team has actually been hard at work extracting almost all of the plugins that were historically bundled with the Packer core into their own repositories. They're already extracted. The reason you haven't noticed that, even if you're in the Packer 1.7 release series, is because then we're vendoring those plugins back into the Packer core. And that means that the Packer core still has those bundled in its own way. But as of the 2.0 release series, we're going to be removing those from the plugin core. And that means that Packer init is going to be required in version 2.0. We're going to stop vendoring in all those external plugins, and Packer init is going to be the way not only to retrieve community binaries, but also to retrieve all of the official binaries that are maintained by HashiCorp currently that used to be bundled in with Packer and now live in their own repositories. Packer init is optional right now, but it is going to be required. And we don't take that lightly. We understand that implementing new workflows can feel really disruptive, and we are here to help. We want to make sure that by 2.0, it's as easy as copy-paste to get the initialization configs up and running and to get Packer builds chugging along as they always were. And of course, if you're in the Packer 1.7 line and you're happy, there's absolutely no rush for you to upgrade. Now, one reason that it's so important for us to make sure that the 1.7 release speaks the language of multi-component plugins, rather than releasing multi-component plugins as part of 2.0, was to make sure that you have this long, leisurely window in which to start using Packer init at your own pace, figure out how it works without having to worry about the other major changes that are coming down the pipe. And we want you to be able to do this now to download externalized plugins. Requiring init is going to be a really good idea, even though it's not necessary at the moment, and here are a few reasons why. First off, it makes sense to enforce plugin versioning, and making sure that you know what plugin version a particular set of Packer templates uses means that you're not going to have those nasty surprises. It allows for easier auditing of the tools you depend on. It explicitly documents what you're using, where you're installing it. And third, it makes the Packer binary much, much smaller, which means that we aren't installing a ton of packages that you don't want or use. Especially for our users who are doing things like downloading Packer as part of a CI run, this is hopefully going to make their CI runs a little bit less hairy, a little bit easier, a little bit less flaky. And finally, moving everyone to this mechanism makes it so much easier for community members to create plugins that are actually accessible by the community, because it means all users are by definition comfortable with installing external plugins, and that means that all community members are going to be willing to install external plugins. And since these plugins are going to be external, whether they're official or community maintained, it's no extra lift for users to adopt community pieces, and I think that's going to be a big deal. You can also install plugins the way that you always have. Manual installation will still work in the situation where you cannot use Packer init for whatever reason. If you end up doing that, you'll just omit the required plugins block that I showed earlier. And you do have to make sure that the multi-component plugins you're installing are compatible with version 1.7 or later. All of the details about manual plugin installation options can be found in the plugins section of the docs website. The next major change that we're going to do in version 2.0 is that Packer is only going to support HCL templates moving forward. And we've given talks in the past about why we're so excited for HCL. This talk doesn't really have the time to be an HCL template tutorial, but the good news is that we have put a lot of work into creating those tutorials, and you should be able to find the resources you need. You can use the HCL2 upgrade command to upgrade your JSON templates to HCL templates today, and we recommend doing this as soon as possible to get a feel for the new format. Again, there's no rush in doing it, but doing it now before it's required is going to make your life much, much easier. If you run into edge cases where the HCL2 upgrade command doesn't work as expected, we would love for you to reach out to us for assistance on the GitHub issue tracker so that we can make sure that command works not only for your use case, but for everyone else's as well. So let me walk you through a couple of reasons why I think you're going to love HCL templates in an effort to entice you to upgrade before Packer 2.0. The first is that the HCL format supports Packer init and the associated required plugins block, whereas the JSON templates don't. Second, HCL2 templates parameterize builder configuration in a way that allows you to reuse builder configurations across multiple builds. What this means is that you can store a build's configuration across multiple different files, and that allows you to reorganize and reuse Packer templates in a way that really works for you and your particular organization's use of Packer. Third, HCL templates support comments using a variety of syntaxes anywhere in the template, which is something that JSON templates simply don't. And fourth, HCL supports variable types other than strings. It supports lists, it supports numbers, it supports maps. And anyone who's ever tried to use a JSON template to pass in an array understands how huge of a headache that is right now and how much better it is to be able to create a variable that can immediately map to an array type input. And finally, HCL templates get all of the HCL language functions for free, which enables all kinds of really sophisticated in-template string parsing, numeric functions, date-time stuff, filtering, and lots more. You're going to be able to have a lot more dynamic use of your Packer templates and hopefully a lot less hard coding of variables or a lot less complicated scripting around your Packer build to get it working exactly how you want it to. It's outside of the scope to give you a run through of all of the Packer HCL templates, like I said before, but there are a few really great resources that you can reach out to get started. The first one, this is a link to the HashiCorp Learn website, and that'll walk you through all of the major aspects of Packer functionality in an HCL template written from scratch. It'll show you how to use Packer init, how to use required plugins, how to create variables, how to do all kinds of only and except filtering. Everything that you know and love about Packer currently, we have a tutorial on Learn to tell you how to use it in HCL. And finally, here's the exhaustive HCL reference documentation in Packer's website. If your question is not answered in that reference documentation, again, open an issue and we will write a new doc to make sure that your question is answered. So now that we've finished talking about those two major pieces of Packer, I want to give you a little bit of a sneak peek into some of the other things that we're thinking about right now. One of the major benefits to doing these two big architectural changes is that we remove a lot of limitations that came with supporting both the JSON format and the HCL format, and the new plugin structure also gives us a lot more flexibility. In the future, supporting more modular things is going to be a lot easier for us, and it's going to give us a much more flexible template style that has a lot of opportunities for enhancing your experience. So here are a couple things we're thinking about. The first is, and this is not officially on our roadmap yet, but it's definitely in our minds as we think about what major improvements we want to make on a post 2.0 Packer. The first thing is we're thinking of is having multiple communicators being able to configure per build. And having that happen so that you can reconfigure your communicator at different build stages will hopefully help resolve some of the issues that we've seen with users when they're trying to harden Packer images for security purposes, or when they have to reboot and they accidentally lose the IP address that the communicator was trying to use to connect before. This is something that's really hard to implement the way the JSON template build is architected, but we think it's going to be a lot more manageable to do once we only have to support HCL templates. So this also isn't on the roadmap yet, but the reason I'm sort of saying these things, even though they're not official, is because you're looking at my personal wish list for the tool right now, and as the lead engineer for the tool, my personal wish list tends to sort of turn into the roadmap a little bit down the road. The next thing I want to bring up is reusable provisioner configuration. Now, having reusable provisioners makes a logical next step, given the fact that with HCL, we've already introduced parameterized builder sources. And with builders being reusable and provisioners being reusable, that allows us to have a dramatically more concise and modular set of Packer templates available to you. And that will hopefully save a lot of users from a lot of copy-pasting nightmares. This is definitely something that we want to implement during the 2.0 series. Now, the final thing is actually something that is on the official roadmap, which is that we're working on an image pipelining tool for Packer in collaboration with the HashiCorp Cloud Platform team. I don't know if you got a chance to see my brief guest spot in the keynote earlier, but if you didn't, I'd recommend watching it. The TLDR is basically that Packer is going to be able to reach out to the HashiCorp Cloud Platform to keep track of your image's metadata in a centralized location. And those data, for example, data about your most recent build, are going to be accessible to Packer and even to Terraform via data sources, which will allow you to remove whatever glue scripts or operator copy-pasting you're currently doing to try to link the two right now. This is not only going to streamline the Packer Terraform interface, but it's also going to make Packer iterative build pipelines much, much easier to track. You'll be able to track image versions, you'll be able to link those image versions to GitHub SHAs if you want to, and you'll just generally be able to improve the visibility around your image factories. And we're really excited to give this to you either as part of 2.0 or even potentially slightly before, albeit as an HCL only feature. So thank you for spending some time with me today and for humoring me as I shared a little bit of gossip around what we're going to be doing with Packer coming soon. I'm really excited for the next year for Packer, and I'm really excited to see what awesome things the community comes up with now that we've implemented some actual enablement and laid the groundwork for you to be able to thrive more. If you have any questions, I hope you've been throwing them into the various chats, but if you miss those, you can always reach out to us via the GitHub issue tracker or on the HashiCorp Discuss platform. And if you have any bug reports or feature requests, the GitHub issue tracker is being paid attention to by my amazing team, and we would love to hear from you. So with that, I just want to say have an amazing day. I hope the rest of your HashiConf EU is as informative as you are hoping. Have a great day.